918 words within the 900 plus or minus 5% range. Here's the final script. Right now, Boyajian's star is still flickering, dimming, brightening, dimming again in patterns nobody can predict, and astronomers at Yale have no way to stop it or explain it. This star has dropped in brightness by more than 20%, not once, over and over. Nothing natural should be able to do that, and what they found when they looked closer is the part they still won't say out loud on camera. But here's what nobody is telling you. Its name is KIC 8,462,852. Most people just call it Tabby's star, after Tabitha Boyajian, the astronomer who first flagged that something was wrong. It sits about 1,000 light-years away in the constellation Cygnus. An ordinary yellow-white star, slightly larger than our Sun. Nothing about it should stand out. In 2015, the Kepler Space Telescope was watching it, along with 150,000 other stars, hunting for the tiny, regular dips that planets cause when they pass in front. It wasn't a machine that caught it first. It was ordinary citizen scientists, volunteers scanning Kepler's raw data by eye, who noticed the light curve looked wrong and flagged it for the professionals. Tabby's star didn't dip like a planet. It didn't dip like anything. The light dropped sharply, unevenly, by amounts far too large for any planet. Then it came back. Then it happened again. A planet crossing a star blocks maybe 1% of its light. Tabby's star lost 22%. In one dip, that's not a planet, that's not even a large planet. To block that much light, you would need something enormous, something roughly half the width of the star itself. And it wasn't just one event. Kepler recorded dimming episodes for years, with no fixed rhythm, no clean orbit, nothing that matched a single object circling on schedule. Some dips lasted days. The shape of the light curve was jagged, asymmetrical, like something irregular was tumbling through the light. Astronomers ran the data through every model they had. Comets, asteroid collisions, instrument error. Every explanation came back incomplete. And that's when a few researchers, half joking and half serious, floated the idea that still won't go away, that they might be looking at construction. An alien megastructure built to harvest a star's energy, drifting across our view of it. Here's where it gets worse for the comet theory, which was the leading explanation for years. Comets could explain occasional, irregular dimming, a swarm of shattered, icy bodies crossing at random. But comets don't explain the long-term trend underneath the dips. Between 2009 and 2013, Tabby's star dimmed gradually by nearly 20% overall, a slow fade layered underneath the sudden crashes. Comets don't do slow fades. Comets don't coordinate with each other over 4 years to dim a star gradually while also causing sudden 22% plunges. Harvard astronomers modeled thousands of comet scenarios and could not make the numbers work without inventing an implausibly large swarm, one that should have been visible in infrared and wasn't. The dust wasn't glowing the way broken comets should glow. Whatever was blocking the light wasn't behaving like rock or ice at all. So in 2017, more than 100 astronomers around the world pointed their telescopes at Tabby's star at once, waiting for the next dip, determined to finally catch it in the act. It came. And in 2019, a team pointed different telescopes at different colors of light, trying to settle it once and for all. What they found was the detail that changes everything. Solid objects, a planet, a megastructure, a swarm of comets, block all wavelengths of light roughly equally. But when Tabby's star dimmed, blue light dropped more than red light. That's not what a solid object does. That's what dust does. Fine dust with particles smaller than a micron drifting between us and the star. Case seemingly closed. Except nobody can explain where the dust keeps coming from, why it forms in these specific, uneven bursts, why the star also faded slowly for years, and why over a decade later the dimming keeps happening on no fixed schedule at all. The dust explanation tells you what? It has never explained why or where it's produced or why this star out of 150,000 watched does this and nothing else does. And that's the part that should unsettle you more than any megastructure ever could. We built a machine that stared at 150,000 stars for 4 years looking for planets. It found something behaving like nothing in our models, nothing in any textbook. We ruled out aliens. We ruled out simple What's left is a mechanism nobody can name, still active, still unpredictable, sitting 1,000 light-years away, still dimming on its own schedule. If a single ordinary-looking star can do something this strange without us understanding why, the question isn't really about Tabby's star anymore. It's about how many other stars out there are doing the exact same thing, quietly, unnoticed, because nobody happened to be watching closely enough to see it. Newer telescopes, including Webb, are already lined up to watch this star the next time it dims. Nobody knows when that will be. So what is actually passing in front of that star right now, tonight, that we still don't have a name for? Tell us what you think is really out there in the comments.